we're looking at trig, identities, inverses, and equations. An identity is an equality relating one math expression to another math expression. Let's take a look at some of these identities. Reciprocal identities are seen below. So sine of x equals 1 over cosecant. Cosine of x equals 1 over secant. Tan of x is 1 over cotan. Secant, 1 over cos. Cosecant, 1 over sine. Cotan, 1 over tan. We remember sine, cosine, tan. We remember that sine goes with cosecant, cos goes with secant, and tan goes with cotan. When we look at even and odd identities, we see the following. For odd, when we have f of negative x, that's equal to negative f of x. Sine negative u is equal to negative sine u, etc. Even, we might see f of negative x is equal to f of x. Cos of negative u equals cos of u. Let's look at f of negative x is equal to f of x. Let's see what happens. So let's say we have a function, f of x is equal to x squared. Let's say that's our function, right? F of x. And let's say in the parentheses, we now insert negative x. So f of negative x equals negative x squared, which is x squared. So f of x, if that equals x squared, and f of negative x equals x squared, we say that that's even. If we were to graph both of those, we would see that parabolic shape. Notice that there is symmetry about the y-axis, right? So if this is our y-axis, a point here is reflected over here, a point here reflected over here. So for even, we reflect over the y-axis. Odd, there's a reflection over the origin. So for example, if you saw something like this, that would be odd. You take a point, let's say up here, you reflect it over the y, lands there, and then you reflect over the x and it lands there. So odd, there's a reflection about the origin. Flips across the x and the y. Let's look at our quotient identities. So our quotient identities are the following. Tan of x is sine over cosine. Cotan of x then is cos over sine, right? And then lastly, we're going to look at our Pythagorean identities. We see in here that sine squared plus cosine squared equals 1. Now we get that because if we create a triangle, when we're talking about our unit circle and stuff, right? We say our radius is 1. Whenever we find a spot on our unit circle, we always say cos is in the x spot, sine is in the y spot. So if left and right represents our cos or our x, we say that this is cos x. And if up and down is y, we say this is sine of x. And using your Pythagorean theorem, you know that a squared plus b squared equals c squared. So instead of writing a, we write cos squared. So cos squared plus, instead of writing b squared, we write sine squared x is equal to c squared 1 squared, which is 1. Now, once you have that, you can rearrange to get all of the following beneath it, right? If I take sine squared plus cos squared equals 1, and I choose to subtract sine squared x from both sides, you have cos squared x equals 1 minus sine squared x. If you want to isolate sine squared, you have to subtract cos squared x from both sides, right? Then if you look over here on the right side, you see 1 plus tan squared equals secant squared x. You see 1 plus cotan squared equals cosecant squared x. Now, one thing that I do is when I'm doing these identities is I always remember sine squared plus cos squared equals 1, and then I'll rearrange stuff and find all of the other identities. So for example, if I start with sine squared x plus cos squared x equals 1, I always write that on my paper first. If I divide all of these by sine squared x, well, we know sine over sine is 1, right? Sine squared over sine squared is 1. We know that cos over sine is cotan, right? Cos over sine is cotan, so cotan squared x. And 1 over sine, right? 1 over sine is cosecant squared x. So that's this one over here that we called letter C. Then, if I go back to sine squared plus cosine squared equals 1. Let's do that again. Sine squared x plus cos squared x equals 1. If I divide all three terms by cos squared x, then we end up with sine over cos is tan, so that's why we get tan squared x. Cos squared over cos squared is 1. Same thing over self, right? And 1 over cos squared is secant. 1 over cos is secant, right? So secant squared x. And then from there, based on what you need, you can manipulate and rearrange. We're going to look at these 6 problems. So we're going to simplify the trig expressions using our identities. Let's look at number 1. I often say, let's try to work with sine and cosine. Let's play around with sine and cosine first. I don't want to distribute. If I distribute, it's going to get messy. I'm trying to simplify. I want to try to work with sine and cosine. So I'm going to replace tan with sine over cos. Usually you get somewhere if you play around with sine and cosine. Now secant is what? 1 over cos or 1 over sine? It's 1 over cos. I'm going to work inside parentheses first. Now the denominators are the same, right? These are fractions. Denominators are the same, so we can write cos x in the denominator. And in the numerator, we have sine of x minus 1 on the outside, we have cos x. Now we can simplify. We know that cos x we can put over 1. If this is product, cos x times the quantity, sine x minus 1 over cos x, these cos x's cancel. And our final answer would be sine of x minus 1. We can't simplify the expression anymore. Let's look at the second one. So for number 2, I usually get somewhere by playing around with sine and cosine. So let's rewrite secant. Secant goes with cos, so 1 over cos of x. Cotan we can rewrite as cos over sine. Now we know it's a product, right? Secant times cotan. So I rewrote them using sine and cosine. Again, that usually gets you somewhere. If I extend this line, we can cross off cos x in the numerator and denominator. So we have 1 over sine of x. And we want to try to get rid of fractions. So we know 1 over sine x goes with cosecant x. So our final answer, our simplified answer, is cosecant x. Let's look at number 3. So for number 3, we are looking at this and we see squared. So when you see those squareds, right, you're often thinking, okay, let me go to these Pythagorean identities and ask myself, can I replace something with sine of x plus cos, sine squared x plus cos squared x, right? Is there something I can do? I can substitute, replace. So I start writing out or thinking about those identities. Over here, is there something you can factor out? Yes. Here's one term. Here's another, right? The plus or minus separates the terms, the parts or terms. The first and second both have cos squared in common, so we can factor out cos squared x. If we do that, what's left is sine squared x plus cos squared x, right? To get the second term, it's cos squared times cos squared is cos to the fourth. Now, if we're thinking about our Pythagorean identities, we know that sine squared plus cos squared is 1. So we can replace this inside with 1. And cos squared x times 1 is cos squared x. We used our identities to simplify. Number 4. Now, for this one, we are going to rewrite this. We'll write negative cotan of theta over negative cosecant of theta. We want to play around with sine and cosine. So I'm going to rewrite this as numerator negative cotan of theta divided by my denominator, which is negative cosecant theta. On the left, I want to work with sine and cosine. So I'm going to replace cotan with cos over sine. I'm going to replace cosecant with 1 over sine. We can change division to multiplication, and we'll flip the fraction on the right. So we have negative sine theta over 1 times negative cos theta over sine theta. Because it's product, we can extend this line, and we have sine in the numerator and denominator, and a negative times a negative is a positive, and cos over 1 is just cos. So our final answer is cos theta. 2 more for this video. This one's a little bit messy. Number 5's kind of messy, right? So we need to kind of play around with this a little bit. Often you want to think, okay, can I work with sine and cosine? Check. We already see sine and cosine. You also want to think, can I factor stuff, right? In the last one, we were able to take out a GCF. If you look at the top and think of it as 2x squared plus x minus 3, right? Pretend where you see x, you have that word sine inserted. Sine squared x, sine x, right? So pretend you're looking at 2x squared plus x minus 3. Ask yourself, can I factor this? What combo, is there a combo that multiplies to AC 2 times negative 3 or negative 6 that adds to b? B is 1, right? Coefficient of x. If we play around with it, we know that 3